talking about perpendicular and angle bisectors. Okay, so the first thing is you should have had some theorems on the website that you should have seen, one of which being the perpendicular bisector theorem. And by the way, you're going to need a compass and glue stick for your graph grid on this set of notes. So the perpendicular bisector theorem just tells you that a point on the perpendicular bisector of a segment is equidistant from the endpoints of the segment. Meaning, if M is the perpendicular bisector, then any point on line M is, if I do any point, the distance from this point to the endpoint, one endpoint of my segment, is equal distance to this point to the other end of my segment. Okay, so that's true for any point you could possibly draw on the graph. These lines, this line would be congruent to this one. This line would be congruent to this line. This line would be congruent here, and so forth. Okay, all of those would be congruent. So from here, we're going to go ahead and prove the perpendicular bisector theorem. Okay, so the perpendicular bisector theorem starts with the given that QM is a perpendicular bisector of AB. Okay, again, that's given. Well, since it's a perpendicular bisector, then QM is perpendicular to AB. And since so QM is perpendicular to AB by definition of a perpendicular bisector. Okay, if QM is perpendicular to AB, then you know that angle QMA is is a right angle, and you know that angle QMB is a right angle. If these are both right angles, you also know that all right angles are congruent, so we know that angle QMA is congruent to angle QMB by all right angles are congruent. Okay, so from here, we also know that QM is a bisector of AB, and if QM is a bisector of AB, then we can say M is the midpoint of AB by definition of segment bisector. If M is the midpoint, then we know that AM is congruent to MB by definition of midpoint, which we can then mark our picture for. AM is congruent to MB. Well, at this point, you're probably trying to think, what are we trying to do? Well, if we're trying to prove that AQ is congruent to QB, it already talks about these line segments. So we want to go ahead and draw them in. If we want to prove them congruent, we can draw in the lines. And we don't have to say auxiliary line because we know it's already saying that we want to prove that those segments are congruent. So it's assuming that you know that there's a distance between those two segments. But if you draw them, you can see easier that these form triangles. If we can form the triangles congruent, then you would know that these two segments are congruent. So to form the triangles congruent, I can now say, well, we know that QM is congruent to itself by the reflexive property of congruence. And if QM is congruent to itself, then you can see that these two triangles are congruent by side angle side, side angle side. So we could say triangle QMA is congruent to triangle QMB by side angle side congruence postulate. And then I realize you probably don't have to have that QM is perpendicular to AB because we know that from a perpendicular bisector. I added that segment in and that's okay, but it is going to make me have another step. So step 10 would be that AQ is congruent to AB by CPCTC. Corresponding parts of congruent triangles are congruent. And if you think about it, If Q were anywhere on this perpendicular bisector, this proof would still be the exact same way, which proves that any point, the distance from any point on a perpendicular bisector to the endpoints of a segment, of the segment that it bisects, are always going to be congruent. From here, we're going to talk about the angle bisector theorem. Okay, this one we're not going to prove, but it is also on the paper that you need to write down this theorem, is the angle bisector theorem is a point on the bisector of an angle. If a point is on the bisector of an angle, then it's equal distant to the sides. Now, the shortest distance from one point to any side is always going to be the perpendicular distance. So if you take a point anywhere on an angle bisector and you draw the line perpendicular to the sides, then they're equal distance every time. Okay? So make sure you know that one as well. And then also know the converse of the perpendicular angle bisector theorem, which says if these two segments are congruent, then you know that Q is on the perpendicular bisector. So if two segments are congruent in a triangle where the points are on a line intersecting the segment, you know it's on the perpendicular bisector. All of those are on the theorems list that's on the website. Okay? From here, what we're going to do is we're going to practice writing the equation of a perpendicular bisector between a segment when you're given the 2 points. Well, first off, you have a graph. Go ahead and glue your graph grid into your notes at this point, okay? So we're going to go ahead and label point A at -1, 6. I'm going to go -1, 6. This right here is point A, and then 3, 4. This is, 3, 4 right here. This is your point B, okay? Now, if I were to go ahead and connect those with a segment, which would be line AB right here, okay? So from here, the first thing you want to do is find the slope. Well, you can use the slope formula, y2 minus y1 over x2 minus x1, or the easy way in this case is to use rise over run. Our slope is rise, which is plus 2 over the run of -1, 2, 3, 4. So 2 over -4 gives us a slope of -1/2. When we find the slope, if we're trying to find the perpendicular bisector, then we need the perpendicular slope. So if our slope is -1/2, then our perpendicular slope, you know, would be +2 over 1 or just +2. From here, you want to find the midpoint of this segment. Okay, so we're going to use the perpendicular slope, and then we need to find the midpoint, because using the midpoint, then we can find the perpendicular bisector. So our midpoint formula, if you remember, is x plus x over 2 divided by y plus y over 2. So I'm going to say -1 plus 3 divided by 2, comma, 6 plus 4 divided by 2. And remember, guys, if you forgot these formulas, you should have an orange formula sheet that you got at the very beginning of the year. It's also posted under LHFC student documents as this formula chart. Look under the geometry one. So for midpoint, x plus x over 2, -1 plus 3 is 2 over 2. 6 plus 4 is 10 over 2. So our midpoint is then 1, 5, which you can see on this picture at 1, 5 right there. That's your midpoint. Okay. From here, in order to get the perpendicular bisector, you're going to use the perpendicular slope, which is +2, and your midpoint, which is 1, 5, and write the equation of the line using this point slope form. Okay, so point slope form, if you remember, is y minus y1 equals your slope times x minus x1. You'll label your point x1, y1. Your perpendicular slope is your m. Okay, so from here, you have y minus our y1 is 5 equals your slope, which is our perpendicular slope of 2, times x minus our x1 is 1. Okay, that's in point slope form. We want it in slope intercept form. So from here, you're just going to solve for y. So y, that should just be a minus. Y minus 5 equals 2x minus 2 when I distribute that 2. If I add 5 to both sides, we end up with y equals 2x plus 3. This is the equation of the perpendicular bisector of that segment. Okay? That's the perpendicular bisector of segment AB. If you were to graph it on your graph grid, then what you're going to do is you plot your y-intercept, which we see is 3. So go to 0, 3. Then we're going to use our slope of 2. So rise 2, run 1, rise 2, run 1, or negative 2 over negative 1. And from here, you can just draw in your line. Well, your line is just going to go through these points. And we know that this is now the perpendicular bisector of that line. Okay? So you've written the perpendicular bisector. Now you also know that at this point, if we choose any point from here, this to A, this line to B, those are going to be congruent because they're on the perpendicular bisector. If I went from here to A, from here to B, I know that those would be congruent. If I went on this side from here to A, from here to B, using my perpendicular bisector, I know it forms congruent segments. Okay, so make sure that you understand that concept. Okay, so from here, what we're going to do is construct the perpendicular bisectors of a segment. Okay, so in order to do this at this point, you are going to need your compass, because we're just going to be doing constructions of perpendicular bisectors. So go ahead and get out your compass. So from here, what I want you to do is just use a straight edge and draw a really big triangle on your paper. Okay, you can label your angles, side A, B, and C, and we're going to construct perpendicular bisectors. Well, for a perpendicular bisector, all you need is a segment, so we can construct 3 in a triangle. Okay, there are 3 perpendicular bisectors in every triangle that you can construct. So again, the first thing you're going to do is put your compass, put the metal part on the end point of one of your segments. Then go ahead and open up your compass to over half the length of your segment. Okay, I'm going to start off with segment AB. You want to open it up to a little over half and go ahead and draw an arc. Draw like a semicircle, okay? From here, leave your compass open to the exact same amount. Put the metal part on the opposite endpoint and draw another arc mark. Don't move the intersection, or don't change the width of your compass. From there, just bring your straight edge up, connect the 2 intersection points. Then you're just going to draw a line and extend this line all the way through your triangle. So if this is a perpendicular bisector, then you know that it's perpendicular, and if we called this M, MB is congruent to AM. Now, we can do the exact same thing on another segment in your triangle, okay? Go ahead, take your segment, again, take your compass, put the metal endpoint on the endpoint of a different segment, open your compass up to over halfway, and then draw an arc mark. Okay, move your compass to the other and then draw another arc mark. And you're now going to, once again, connect to the 2 endpoints. If you've gotten this one, I want you to go ahead, do a perpendicular bisector of the 3rd side. Okay, so once again, here's our perpendicular bisector. You're going to do the same thing for the 3rd side. Now, if you notice, all 3 of your perpendicular bisectors should intersect at one particular point. Okay, that's your intersection of your perpendicular bisectors, which is called your orthocenter. Okay, we're going to talk more about that later, but just make sure that you understand how to construct perpendicular bisectors. Okay?